Next topic is Zener Diode as a voltage regulator. So here you can see in circuit diagram on the left hand side, that is we can say at input point we have unregulated DC input. It is means the wave which is coming, it is like little bit fluctuating. It is not exactly same, and we want a straight line. Okay, that is called regulated output voltage. So what we'll do, we will add a Zener diode in a reverse bias. Now see how it is reverse bias. So here we have a positive terminal, and this positive terminal is connected through resistance Rs, and it is connected to the N type. Okay, and this negative terminal of the input is connected to the P type. So we can say it is in reverse biased. Clear? Now ahead, this Zener diode is connected in parallel with a load resistance. Across the load resistance, we will take here V output. Okay, so by Kirchhoff voltage law, we can say that voltage input is equal to voltage across Rs resistance plus voltage across Zener diode. Okay, so the voltage across these 2 points, voltage across, can you see? Voltage across these R across Rs is nothing but I into Rs plus Vz. Now here we can see that current I will pass, and this current I will pass through resistance. Small part of current will pass through Zener diode and remaining part will pass through IL, that is a load. Okay, this IL. Clear? So can we say that the total current I is equal to Iz plus IL, right? Okay. Now see, we have Vi is equal to IRs plus Vz. Now we want here output. The output means we want Vz, which is equal to Vi minus I into Rs. Now let's take an example, because see here we want a constant voltage. Let's example, we want 5 voltage constant output. Okay. So let's take an example. Rs is equal to 1 ohm and V input, that is unregulated DC voltage that we are providing, that is of 10 volt. So we will get first Vz is equal to 10 minus, and assume that current is coming of 5 ampere into I into Rs is equal to 10 minus 5 into 1. So we will get 5 volt. Okay. Now second example, same Zener diode, we are increasing the input voltage. For example, it is 15 volt and value of Rs will remain the same, that is a 1 ohm, and we got current is equal to 10 ampere. So again we will substitute. So we will get Vz is equal to 15 minus 10 into 1. So at the end you will get again 5 volt. Okay, that is called. And similarly you can add another one example. For example, Vi is equal to 20 volt. As we know that from the Ohm's law, as the voltage increases, so your current also increases. So as we increase this V input, the current passing through that circuit is also increase. Okay. So Vi is equal to 20 volt, I is equal to 15 ampere, and Rs will remain the same, that is 1 ohm. So again you will calculate Vz, you will get 5 volt. So from using Zener diode we get a constant regulated voltage output. Clear? So in this way we can use Zener diode as a constant voltage regulator. So here we can conclude that when the input voltage increases beyond a certain limit, the current through the circuit rises sharply, causing a sufficient increase in the voltage drop across the resistance Rs. Thus, the voltage across Zener diode remains a constant, and also the output voltage remains constant at Vz. But when the input voltage decreases, then the current through the circuit goes down sharply, causing a sufficient decrease in voltage across the resistance. As a result, the output voltage will again remains the constant. Okay. So as we decrease the value of Vi, so we can say current also decrease, and due to which the voltage drop also decrease. Voltage drop across Rs decreases, and due to which we will get a constant regulated output voltage. For example, let's take, this is our reference point. Okay, this is our reference point. Now if you increase the value of Vi, still you will get a 5 voltage, and if you decrease input voltage, that is a, for example, here, So if you decrease the, here it was around 15 volt, right? So if you decrease the 10 volt, then also you will get a constant voltage 5 volt. Thank you.